This presentation discusses our rapid deployment and post-storm reconnaissance of Hurricane Laura. I am Navid Jafari at Louisiana State University. My colleagues Jack Cadigan at LSU and also Jim Chin at Northeastern University are my co-authors. I'll start with an introduction of what we did right before Hurricane Laura, discuss some of the instruments we deployed, some of the reconnaissance surveys afterwards, and then some preliminary results followed by summary. When we were making the decision to deploy for Hurricane Laura, it was a unique time in the Gulf of Mexico because there was two storms, Hurricane or Tropical Storm Marco and Laura, and they were to some degree interacting. And so with Marco hitting Louisiana a couple of days before Laura, it almost seemed like we would not be able to deploy. But Marco changed tracks around August 24th, around midday. And that gave us the window to deploy the next day. And at that point, we had August 25th, we deployed, but we had the equipment from the University of Washington Murray Rapid Experimental Facility, and we obtained permission to deploy at Rockefeller Refuge. And by that evening, we had the equipment prepared, and we deployed early morning that day with support from T. Baker Smith with an airboat. And then about a week to 10 days later, after all the surge waters had receded, we were able to go back and collect the sensors and document any damage from Highway 82 all the way to Cameron, Louisiana. So here is the path of Hurricane Laura. Before the storm, it was initially shifted over to the west, so that way the surge was actually going to pass right through Calcasieu Pass and go into Lake Charles, and that's what made this air quotations unsurvivable based on the media. But at the last second, it shifted to the east, right across the Cameron. And so our study site was Rockefeller Refuge located here. It was originally going to get around 5 to 10 feet of surge, but because this track shifted to the east, it felt it was the hardest hit areas in terms of storm surge. When we were looking at the CERA predictions, we saw about 13 to 16 feet of surge or inundation, and anywhere from about 5 to 6 feet of waves. So really our site ended up being an area that was impacted the most by Hurricane Laura. Our deployment was focused in two areas. Rockefeller Refuge is located here, and we had a series of sensors here. And then we also, to get better spatial coverage, we extended our sensors to the west, all the way along Highway 82 towards Cameron. And then we also placed sensors in Cameron so that way we could capture any overland flow in a more urban environment. At Rockefeller, we had sensors located on a lookout tower, one up at the top to measure atmospheric pressure, one at the bottom to measure surge as it moved further inland. And then we had one offshore wave gauge. And then we had two transects, one where there were breakwaters, one where there were not breakwaters. So we could see the difference between shoreline erosion, surge, and wave due to the impact of breakwaters. At each one of these wave gauges along these transects, we also place sediment tiles so we can document sediment deposition. And we also put water level sensors from the Rapid Experimental Facility to measure the in situ pore pressure in the soil. Above that, we also took some drone surveys of the shoreline. We installed time-lapse cameras at the lookout tower, and we took elevations as well. So here are several photos. We put a wave gauge right on the shoreline, and we also bored about 1 meter into the ground to put our water level sensors. and then just covered them up. And then here's some photos of the wave gauge, and also just broad views of the wave gauge. Here are some photos post-storm. So this is after the storm itself. We went out to the area and collected or recovered our instruments. We conducted again aerial surveys with the drone, and we collected post-storm vegetations because we had collected vegetation samples before the storm. We again made elevation transects at the shoreline and in general documented any damage. So obviously, because this area felt the highest storm surge, there was a lot of damage along Highway 82. These are just some photos here. One thing that we did notice quite often was there was evidence of overtopping backside scouring of Highway 82 along the stretch just east of Rockefeller Refuge. And so you can see here that the water flowed over the pavement. The hydraulic jump created likely eddies that allowed this backside to be scoured and at least scour the subbase of the pavement and just deposit it right next to it. Another observation was all the vegetation was bright and healthy before the storm, but after about 10 days of inundation, they had turned brown. And so it'll be important to keep track of how these vegetation recovered. Here is a video of the shoreline. You can see before breakwaters, and then this is the section with the breakwaters. You can see the shoreline morphology before the storm. And so you can clearly see the mud flat, and the elevation comes up to kind of a ridge with this sand beach before it meets the vegetation for the wetlands. So we can see some small fans here pre-storm, and this will be magnified post-storm. And this is what it looks post-storm. So we can absolutely see that the sand has been shifted. Our measurements said at least about 50 feet further inland. And so this small creek here is a nice reference point. The sand has pretty much been shifted to the point that it meets this small creek. And it seemed like to some degree the breakwaters, the stones had been dispersed just a little bit. And overall you can see the brown vegetation. So what were we able to measure? So this is some preliminary measurements. This comes from the water level sensors placed inside the soil. So we're seeing the soil pressure response in the wetlands and the fine grained soils. And we clearly see that after we placed it, as the storm surge was rising, we see fluctuations in pore pressure up to the point when the peak storm comes and it rapidly increases. And if we took the delta of about 105 to 140, it's about 3.5 meters of water or thereabouts. So that's essentially what it equates to for the storm surge. Noticed, interestingly, a small drop when the eye of the storm passed right over the site. And then immediately after the storm, as the waters receded, the pore pressures also receded. So the pore pressures increase quite dramatically, but they don't stay elevated. They actually decrease as the storm decreases. So it kind of lends itself saying that the soil is undrained, but also those undrained excess pore water pressures are not present for a very long time. And so when we went out back in the field, there was still some water on the ground, and this represents that there is a delayed effect in terms of the draining of the wetlands. Here are the two transects that we had. This transect had breakwaters. You can see these small cuts into the levees that built a small berm, and this small creek here where the hurricane pushed all the sand sediment over to that position. So if we compared the elevations between the two, the red squares represent pre-storm, the orange yellow circles represent post-storm, and we can see with no breakwater, this August 24th profile is pretty unique in the sense that it has the peak beach elevation and then it slowly decreases to the wetlands. We can completely see that this was eroded away and shifted inland, creating a new block. So net erosion and deposition within the first about 100 feet of the shoreline. And so in a sense, that first 50 meters was completely eroded and deposited in the next 50 meters. In contrast, we saw at the breakwater that we had essentially the same profile as before as the no breakwater, but we see that the shift inland is less so than the breakwater. So it gives us indication that potentially it's providing some value in shoreline erosion. In summary, we're able to deploy rapidly our sensors for a near Cat 5 hurricane, where we're able to measure water level sensors and wave, surge and wave measurements. The interesting notes in terms of the water level sensors or the measurements so far is that there was about a 3 to 4 meter surge. We did see the eye wall passage through the sensors, and it is evident that the breakwaters make an impact on the geomorphological changes. And there's still a lot to do with the data that we collected. I'd like to acknowledge some of the support that we received to make this happen. T. Baker Smith provided the airboat support. Jason Chauvin and Edmund Griffin greatly appreciated. We received support from the NSF Nearshore Extreme Events Reconnaissance to deploy. And so Britt Rubenheimer, Steve Elgar, and virtual help with Brett Webb were all really instrumental. And they facilitated us receiving equipment from the University of Washington Rapid Experimental Facility. And also Alborz Fadanazad, Jasmine BK, and Patrick Brothers who helped in the field work post-storm, and Omar Uoa, Omar Alowena, who helped post-storm with our virtual team and data processing. Thank you, and I hope you enjoy the presentation. And if you have any questions, please feel free to email any of the co-authors.